All right. Hi, everyone. Thank you for joining us for the last AOS department seminar of the semester. Today, we have a series of three talks given by three speakers who will be presenting these presentations later on in the following weeks at either AGU or AMS. And so with that, I'll hand it over to our first speaker, Margaret Mooney.
Thank you for the opportunity to present. I'll be sharing student content from an undergraduate course on climate and climate change from the UW-Madison. A little bit about me. I work for NOAA's Cooperative Institute for Meteorological Satellite Studies at the UW, and previously I worked for NOAA's National Weather Service in Madison, Wisconsin. And here's a map of all the cooperative institutes that NOAA has. SIMS is the one between the UW-Madison and NOAA. So even though I worked for the Weather Service for so long, I wasn't really aware about the impacts of climate change until I read the 2007 IPCC Summary for Policymakers. And that inspired me to start working in climate education, first with middle and high school science teachers, and then university undergraduates. Fast forward to 2020, we've now offered climate and climate change for 8 summers. And the most powerful part of the course is the discussion forum. The last week, students imagine that they're on an elevator and someone asks them, what do you think about climate change? And then they give their response in 2 minutes or less. So there were 74 videos, and I asked 12 of those students if I could share them more broadly. We're going to look at 10 responses, but of course only subsets from those 10 students. First of all, Frank, I think simply that climate change is the single greatest existential threat that humanity has and will continue to face throughout the 21st century. The science is in. I don't know how to make this any clearer than we need to start actually addressing this issue like it will be the end of humanity, because quite frankly, it will be. And Paige, I underestimated the need to completely reevaluate my morals. I can't even imagine if we all, individually, were able to get rid of the belief that more is better and begin to buy products that are sustainable and ethical and better quality. And we wish there was more being done about it, but our generation is going to be running the world in a few years, and we were brought up and educated in a time when it was being discovered that climate change was a huge issue. I think there's some hope for us because as we move into positions of power, we have a brand new viewpoint about how the environment works and how much we should care about it and what we need to do. Demutu, it shouldn't be seen as political. It's not a topic that people should have sides on. As someone who lives in the United States, I've also come across people who don't realize that climate change has an increasingly worse impacts on second and third world countries. It'll take everyone to make an effort to get educated and reduce this issue. And Nick, he did a great job of explaining the science. Many of the students just tackled the science and really conveyed it really well in less than 2 minutes. I include Nick's quote here because he was exceptional. And Josh, he actually had to upload his video the next day because he was in a power outage because of a hurricane. So he talked about tropical cyclones, and then he talked about subsidies to fossil fuel companies, and that why not use these subsidies for renewable energy. And I just want to say that's not part of the class. We don't talk about subsidies, but Josh says we all know that this has been going on. Let's change it. And Connor, one of my favorites, climate change is the largest threat humanity has ever faced. We're in the midst of a pandemic. We've been through wars. This is the biggest threat. I think it's a hard issue. Renewable energy is a mostly untapped industry in America. If we switch to it now, we're going to have so many new jobs opening up. I think sacrificing certain wasteful practices is worth it if we get more jobs, cleaner air and water, a better future, and correcting environmental injustices. And Mei Lee said we need to talk about it. Seems like there's so much information, it all seems so overwhelming, but I feel like the first place to start making a change is to start having conversations like these and educating yourself on this topic. And Kiara, Regardless of what party you belong to politically, Republicans or Democrats, you should try to learn about the science behind climate change and what it could do to affect you. If everyone in the world, or even just the United States, could take small steps to reduce their carbon footprint and reduce their pollution, we can make great strides in slowing or stopping climate change. But another big thing you could do would be to vote for political leaders who do have plans to slow and reduce climate change. And Kate, going forward in my life, I'm going to try to be more aware of how my choices, whether it be where I shop, how long I keep the lights on, or who I vote for, will affect the world 30 years down the road. So those were some of their elevator speeches, elevator pitches. I think they're all powerful, and you can listen to them yourself if you'd like. Another week, we asked them to weigh in on climate justice and COVID-19. Students were tasked to identify a scenario in the state or region where they grew up, where climate and environmental injustices combine to affect people of color more negatively than white people, and then tie that in with COVID-19. So here's one student's post. I'm not going to read it, but I wanted to show you that these are significant posts with detail. They were by and large quite interesting. And this student says, systematic racism amplifies crises in communities of color, whether those crises be natural, as in weather, or viruses, or overall health in general. Here's another student that wrote about Chicago's south suburbs, and they point out that a disproportionate amount of energy plants are located in these areas, and that African Americans make up nearly 42% of Chicago's COVID-related deaths, while only representing around 30%. And they think the easiest way to spark change is to vote. Local and nationwide elections are more important now than ever. Here's one in Madison, Wisconsin. A lot of detail. I'm going to read a little bit more of this one. Grew up in Madison with national rankings stating that Wisconsin is #1 in racial inequality, i.e. we're the worst. The issue is that there's almost a direct correlation between folks of color and folks who live in low-income housing, have a low socioeconomic status, which is all due to redlining practices that happened in the 1930s as part of the New Deal. Redlining refers to the practice of mortgage lenders drawing red lines around portions of a map to indicate areas of neighborhoods in which they do not want to make loans. This practice occurred through heavy and influential racial bias. They marked off black and brown neighborhoods as undesirable and hazardous, and most importantly, prevented people of color from being able to buy property. One action an individual can take to help rectify these injustices is honestly just to support the Black Lives Matter movement by doing any of the following: donating, protesting, educating, volunteering, contacting elected officials, signing petitions, etc. I don't think people realize how closely connected that movement is to climate movements across the state, country, or world, and it's important to support it. So I just want to jump in and say the class didn't teach anything about redlining. I think the students' post was pretty great, and of course, they post this and they educate all the other students. There were 74 students this summer and 4 seniors. Okay, this student also brought up redlining, but it was from Milwaukee. And they say that the other things that are going on in Milwaukee are food deserts and landfills. The city of Milwaukee's landfill is located on the northwest side of the city, where African American and Hmong communities live, making for worse air quality. And that access to fresh fruits and vegetables has long been a problem in the heart of the city, forcing communities made up mostly of people of color to travel further and pay more for healthier foods. Instead, the neighborhoods in the cities where people of color live are deliberately riddled with fast food restaurants. And finally, New Jersey. The student grew up in New Jersey, and they point out that while they grew up in a privileged upper to middle class community, just 5 to 10 minutes away, communities were labeled dangerous. And in reality, they suffer from not only harmful stereotypes, but also from deeply entrenched systematic racism that threatens livelihoods close to their own. Industries pollute the air and make child absenteeism due to asthma 30 times the average. And they recommend educating others to stop buying from companies who pollute the region and invest in renewable energy companies. So I really think that these responses are very thorough and comprehensive and really point out all the connections between climate change and racial disparities. The student talked about Milwaukee, and at the end he or she say it's voting for politicians that both acknowledge climate change and other forms of systematic racism is a way to combat the issue. So also this year we were able to get a publication in the Bulletin of the American Meteorological Society, and what it mainly consisted of was comparing pre- and post-course surveys that we've been doing for every year, but for this particular article, it looked at 2018 and 2019. So at the beginning, we asked students, how well informed do you feel about how the Earth's climate system works? And pre-course, most of them say not very well informed, and post-course, either fairly well or very well informed. We also had them take a series of science-based questions before and after taking the course, and saw a significant improvement in comprehension and science literacy after taking the course. Well, that's what we'd expect, right? It's primarily a non-major science course, and we expect them to learn the science. But I was also wondering, has anyone who took the course changed any of their personal behaviors? So this past September, I sent out another survey, and I've got about a 40% response rate. And this time I did the students from the summer of 2018, 2019, and then this past summer, asking them questions related to carbon footprint. And the questions, most of them had 3 responses they could reply to. They could choose not at all, somewhat, or a great deal. So looking at transportation, asking that they were driving less and taking more public transport, biking or walking, 83% of students indicate driving less. And I'm combining somewhat and great deal for that response. For air travel, 61% of students indicate flying less. For diet and food waste, 75% have shifted away from red meat. And for food waste, 83% are eliminating food waste. Utilities and purchasing. Household utilities is where they indicated they're making the most changes. 94% are reducing household energy and water usage. And then 85% are purchasing sustainably sourced food and products. So how much ease do they have around communicating about climate change based on the knowledge that they've gained? 92% indicate that increased knowledge makes it easier to discuss climate change and environmental issues with friends and families. How about civic engagement? I asked, have you become more civically or politically engaged since taking the course? And 68% indicated that they are more civically engaged. And the ones who selected a great deal could also type in, have a drop-down box to type in what ways. So you can see the list on the right. They got more involved in political campaigns. One wrote a letter to the editor, and one mentioned being active in the Black Lives Matter movement. I also asked how likely they were to vote, and 94% indicated they were very likely or 100% likely to vote. So in conclusion, I feel like these students touched on practically every issue that's really important right now. They brought up redlining, they talked about air quality, prejudice, subsidies, bias, food deserts, the importance of the vote, Black Lives Matter, renewable energy. It has long been thought that there's a knowledge action gap and that just teaching about climate change doesn't do enough. But I don't think that's true with university undergraduates. They're informed, they care, they're modifying their personal behaviors, they're voting, and they're speaking out. Here's one of my favorite quotes from one of the elevator speeches. And there's the URL if you want to listen to the students themselves, and there's my email if you want to get in touch. Thank you very much.
Great, thanks, Margaret. Does anyone have any questions? Zoe.
Hi, great talk, Margaret. I was curious if you saw any correlation between, or just differences between the year they took the class and kind of those responses of feeling like they've done more. Is there any correlation to the more recently you took it, the more likely you are to do actions?
Well, I guess I could go back and look at that. But what I've noticed just by teaching it every summer is that this summer, I'd say yes, absolutely, but I can't prove it because I've listened to their elevator speeches every year. I've read their discussion posts. I feel like this class this summer was super fired up. And could it be because of the George Floyd incident? Could it be because, as Ree said, we've been raised with this issue? I mean, I have kids like probably all your guys' ages, and they just think of it as part of life and something they need to do. It changes their whole what they want to do with their lives. I feel like people are more aware, more empowered, and this summer they were kind of amazing. I'm not sure how to prove that, though.
All right, we have time for one more question. All right, if there are none, we can. Oh, okay. Liz.
Hi, I'll ask a question. I'm curious, based on the last couple of years, how are you planning to amend or revise the course for the next time you're going around? This is really cool.
Well, we amend it every year. Every spring I update it. For one thing, the climate data is always changing. But that discussion question about connecting racial inequalities with COVID-19, of course, we didn't have that last year. Once we had an activity on the Clean Power Plan, we had to get rid of that. We update it every year after Christmas, usually between AMS and the time the course starts. If anyone's done an online course, most of the work is before it starts. And if anyone has an idea about a discussion post topic for next summer, let me know. Keep in touch. It's the most powerful part of the course. Or if any AOS professor would like to just watch the course, I can add you as an observer.
Great. All right. Thanks, Margaret.
Thank you.
So we're going to move on to our next speaker, who is Scott Lindstrom.
And I'm trying to share my screen, and I'm not getting. I click it, and nothing happens.
I think, Margaret, you need to stop sharing your screen. It's that little circle with a square in the upper right part of the black area. Upper right. That works too. Are you able to now, Scott?
No, I click it and nothing happens. Which is weird because that's not what happened last time I tried this.
So go to the share application screen. Share your entire screen.
I click
on the little window that's down there, and you should be able to share from there.
I click on the purple arrow. I see share application screen pop up.
Yep.
And when I click, I don't see anything. Nothing happens. Nothing appears for me to click on.
Are you using Safari or Chrome?
I think I'm on Firefox.
Interesting. You shared it just at the very beginning of this, right?
Yeah.
Why don't we go ahead, let's skip to the last talk. Why don't you exit out of here, Scott, and come back in, and we'll try
okay.
at the end.
Okay.
All right. So while Scott is figuring that out, I guess we'll move on to Aditya Kumar.
Can you see my screen?
Yes.
Okay, hello everyone. Thank you for this opportunity to present my work in the AOS seminar. So my work is titled WRF-Chem Aerosol Predictions during FIREX-AQ using the GHOST 16 fire product and implementing the uh, FRP-based emissions and Plumerise in the weather research and forecasting model. And this work is a part of the AGU session A255, Smoke in the Air, Biomass Burning Emissions, Chemical Evolution and Impacts on Air Quality and Climate. This is scheduled to be on December 17, 2020. So if you are interested, please join in. And I would like to thank my co-authors, Dr. Brad Pierce, who I work with at SSCC, Alan Lenzen at SSCC, Ravan at NOAA Israel, Chris Schmidt at SSCC, Shuka Schwartz at NOAA Israel and his team, Jose Jimenez at CU and his team, and John Hare at NASA Langley. So starting off with the introduction and motivation for this work, we are mainly working on improving the emissions and Plumerise mechanisms in the weather research and forecasting model. This model currently employs a bottom-up approach which uses the fire burnt area to estimate biomass burning emissions. This has resulted in significant underestimation in estimating the emissions, and this was observed when we provided a real-time forecast during the NASA NOAA FIREX-AQ field campaign, which I'll talk about later. And an alternative approach is using the fire additive power measurements from satellites, and these this approach has proven to provide better emission estimates than the bottom-up approach currently being used in WRF-Chem. So we are using the approach employed in the HER smoke model, which is run by NOAA Israel for providing smoke chemical forecast during wildfires. And it has been doing very well. So we are trying to employ this approach in the WRF-Chem model, which does not have any FRP-based emissions, and no previous evaluation exercises have been performed. So this is a very rough modeling framework for the WRF-Chem version we run at UW-Madison at SSCC. It involves initial and boundary condition inputs from the real-time air quality modeling system, which is a global air quality model. And it uses the GoCard aerosol module to simulate various aerosol species like black carbonaceous aerosols, black carbon, organic carbon, dust, sea salt, and sulfate. And the WRF-Chem version we run is at a spatial resolution of 8 by 8 kilometers. It is nested for the continental US. And for wildfire detections, it uses the GHOST 15 fire detections. Earlier, these were used while we were providing real-time forecasting support for FIREX-AQ. And now we are improving that to include the updated version GHOST 16, using which we will be doing our retrospective runs, which I'll be showing later on. And these give us the aerosol predictions. So this is a list of the new developments in the WRF-Chem model we've done for FIREX-AQ. These include GHOST 16 fire detections and properties, FRP-based fire emissions. These are based on HER smoke, as I had mentioned earlier. An FRP-based Plumerise method, which simulates the injection heights of fire plumes. And these are also based on the HER smoke model. We have derived separate diurnal cycle functions based on GHOST 16 FRP and FIREX-AQ data available. And we have also included diagnostics which provide us with aerosol extinction coefficients. And a current development is improving the temporal resolution of emissions. We are going to hourly emissions, and this is a development which is in progress right now. So just an overview of the GHOST 16 fire product. This is provided by Chris Schmidt at SSCC, and we're using that. So GHOST 16 is a geostationary satellite which provides fire properties every 5 minutes over the continental US. It provides the properties at a spatial resolution of 4 kilometers square. These properties include the location of the fire size, the fire additive power, and the time of detection. And this product has a higher temporal and spatial resolution as compared to the previous GHOST 15 version, which enables us to capture the spatial and diurnal variations in fire behavior in a better way. And these are the diurnal cycle functions that we have derived for the FIREX-AQ campaign. So in the white curve here shows the default WRF-Chem diurnal cycle. It peaks at around 18Z, And this was not a correct approach since fires can peak at different times depending on longitude bands. So we have derived these different functions which you see in the colored lines, which based on the 3 different longitude bands and using the GOES 16 data. So these have different peaks based on the longitude band the fire is observed in, and we are expecting to have a better simulating approach than the previous one employed by WRF-Chem. The overall of the 2019 NASA NOAA FIREX-AQ field campaign. This campaign was held in between July to August 2019 out of Boise and August to September 2019 out of Salina, Kansas. And it had a number of participants from UW-Madison. We were led by Dr. Brad Pierce, who was the leader of the chemical forecasting team, by Alan Lenzen, who provided us with forecasting support, Margaret Bruckner, who also provided chemical forecasting support in the field. Myself, I was also there in the field to provide chemical forecasting support, and Alexa Ross, who provided us with satellite data analysis support. This campaign focused on sampling both wildfire and agricultural fires. So the first phase of the campaign in Boise focused on sampling wildfire in the western US, and the second phase in Salina, Kansas included sampling agricultural fires in the southeastern US. This campaign involved high temporal resolution measurements of several important pollutants and aerosol properties, which I'll show later on. And shown here are pictures of the team in Boise and the DC-8 aircraft, which had all the instruments aboard. And this was a picture of the Williams Flats fire in Washington, which was a major focus of this campaign. So here is a summary of the work that we have done. We are doing retrospective WRF-Chem runs for the Boise phase of the campaign, and the focus of this talk would be on the Williams Flats fire. We have performed runs for the period 2nd August to 8th of August, and all runs include the GOES 16 fire detections. And we have 2 sets of experiments. One is a control run, which includes the default settings in WRF-Chem, and the other is with our new implementations, which includes the FRP-based emissions, Plumerise, and the new diurnal cycle functions. So for this talk, I'm just showing results from one of the flights. This is for the flight on the 3rd of August 2019. So on the left, you see the aerosol optical depth during the flight period for the control run. And shown here is the flight track. We flew out of Boise, and then we covered this Williams Flats fire. And on the right is the same period with the new emissions and Plumerise. So clearly you can see that we get a much higher AOD simulation as compared to previously, which is an improvement, because we were underestimating the AOD significantly in the control runs. And I'll show a validation with the observations in the next few slides. This is a comparison of the aerosol backscatter simulations. So on the left is the control run, and on the right is the run with the FRP, and on the top is the measurement aerosol backscatter from the high spectral resolution LiDAR measurements from Dr. John Hare at NASA Langley. So again, you can see we show the flight track, and we show the backscatter values along the flight track. And as you can see earlier, we were not getting these enhancements in backscatter that we see with the FRP runs, and these agree quite well with the observation as compared to earlier, where we were significantly underestimating. So here are the plots for black carbon measurements. So on the left are the control runs, and on the right are the FRP runs. The top plot shows the flight track along with the contours of black carbon enhancements along the flight track. And in the bottom panel are shown the observations in black along with the WRF-Chem simulated black carbon levels in red. So again, as shown by the yellow circle in the bottom plot, we were very significantly underestimating as compared to observations. But when we include the FRP emissions and Plumerise, we are better able to capture the enhancements, and also we get the peaks. We capture the peaks in a much better way as compared to previously. And this is also shown in the contour plot, so you can see much higher enhancements now as compared to previously. Results were obtained for organic carbon as well. So again, you can see much higher enhancements as compared to the control run, and similar higher peaks as compared to the control run when we use the FRP emissions and Plumerise. So in summary, we have updated the WRF-Chem version at Wisconsin with GHOST 16 fire properties, FRP-based emissions, Plumerise, and diurnal cycles. We performed retrospective runs for the FIREX-AQ field campaign, and evaluation of the model simulated aerosols with FIREX-AQ measurements were performed, focusing on the Williams Flats fire. Our results show significant improvements in our WRF-Chem aerosol simulations when we incorporate FRP-based emissions, Plumerise, and diurnal cycles. And we are working on improving the temporal resolution of emissions in the model. So we are moving to an early emissions approach, and we are doing that currently. Our future work would using these early emissions to again do the retrospective runs for both Poissy and Salina phases of FIREX-AQ. Here are my references, and thanks to our funding support from NOAA, UW-Madison Space Science and Engineering Center, and provided my emails and Dr. Brad Pierce's email if you want to contact us or have any questions. Thank you.
All right, do we have any questions? Okay, if there are no questions, we can move on to our last presentation. Scott, are you able to share your screen now?
It looks that way. Let me just choose the entire screen. Can you see my talk?
Yeah, it looks good.
Okay. Well, thank you for letting me talk about this. This is work I've been doing for a while, and actually, when I received notification that this paper had been accepted to AGU, this is where I'm giving it, I'd actually completely forgotten I'd submitted it. So just a little aspect of COVID with me is I forget what I've done. But this is something I've done with Jordan Girth, who is recently in the building. He's now in Washington, D.C., and Eric Lau, who's the SSD chief in Pacific region. So the challenge that this work attempts to address is that there are always new satellites being launched with new capabilities. There's this gulf between what the algorithm developer wants and can create and what the forecaster has time to incorporate into their work. So there's this need to have a proving ground type structure. So a proving ground is a method where the forecaster who is using the product and the developer who has created it get together in the same space, and the developer gets to watch the forecaster use their product, and then the forecaster can then turn around and say, you know, this product would be better if X, Y, and Z, or I really like how this product does different things. So there's this two-way interaction that it eventually makes for a better product, because the subject matter expert who's developed the product has a better understanding for how the product might be used and for the constraints that a forecaster works under. I don't know how common it is for the scientists developing products from new satellites. How often are they in a forecaster's shoes so they can understand exactly what a forecaster is going through? Because the forecaster doesn't have a lot of time to look at every single product. They need something that gives them great value for not a lot of added time. So my role in this is to familiarize the forecaster with the product before they meet with the subject matter expert. So when you have a proving ground, when you bring together the subject matter expert and the forecaster has to be brought up to speed on what the product is that they'll be looking at and testing and evaluating for the forecaster. So the scientist creates these products, and typically they don't have time to bridge what's called the valley of death between research and operation. So a scientist makes a product that they think is absolutely the best thing, and it will cure cancer almost, and it'll be everything the forecaster needs. But it's a challenge to get a new product operationalized. So NESDIS has to take over the creation of the products. Forecasters have to learn how to use the products. And a challenge for that is, once the scientist creates this new product, they're typically not funded to do more than that. They're off to another product. So we have this issue where you want to make it so the forecaster understands why this is a good product, and then they have a demand for it. So if a forecaster is asking for a product because they know it will help them, then the National Weather Service will say, okay, this is a product we need. Let's take steps to have it get into the forecast office. That might take a long time, but it will happen. So here's just an example of a product that was developed at SINS. The Morphe integrated microwave imagery at SINS total precipitable water. I hope you all look at this daily. It's a great product. The National Weather Service likes it. Tropical forecast centers, RSMCs around the world use this. And it's useful because moisture information is vital for situational awareness. So recent example, there were landslides in Haines, Alaska at the beginning of the month. Mimic TPW showed the amount of moisture that was heading toward Alaska, the atmospheric river. So to create training before a forecaster starts looking at this, I typically create a PowerPoint and a training video. They're linked here if you want to look at them. And I interact a lot with the product developer when I'm doing this. That would be Tony Wimmers at SINS. So we have information on how the product is created. So these swaths of total precipitable water, this is fairly old because it doesn't have the TPW extending over land, and mirrors retrievals now allow that to happen. And then you have how does that TPW move around, because you need to take all these individual swaths and move them backward and forward in time to hourly time steps, so then you can stitch them all together. And then you have something like this. And eventually I made a website for the National Weather Service in Pongo Pongo that said, here's a 10-minute rocking animation that you get every day so you can see how the total precipitable water is changing with time. So that's one way to do it. You make these training videos, you talk to the forecasters, and then they get a product, a customized product that they can look at every day. There are other proving grounds, and I think the most famous one is the Hazardous Weather Test Bed. This is something that happens, well, annually, except this past year, and we'll see what happens this year. But it's a series of weekly events where forecasters are trying out new products, and the scientists are down there to both advocate for their product and demonstrate how they're useful. The forecasters give immediate feedback to the developers. So this process of getting research into operations is streamlined because there's an operations to research feedback, and as I said, it speeds up ways for the forecasters to be exposed to these new products and understand how they can be useful. So the forecasters going to HWT are from forecast offices around the country, National Weather Service forecast offices, and then they go back to their office and they tell all their friends, I saw this great new product. Here's the website, let's start using this in the office. And if enough people do that, the Weather Service takes notice, and then they take steps to get it into either into the forecast office over the SBN or as a product in MRMS. There are different ways to get it in there. So the training that I create here is just short PowerPoints that are turned into videos so the forecasters can look at this beforehand. And then I create short, they call them quick guides, 1 or 2 page documents just to hit the highlights. So after you've taken the training, and if you forget something, you can look at this maybe laminated 1 page or 2 page document that has all the information on it. So I've seen an interesting evolution of products with this. So back around 2010, Sims was creating a cloud top cooling, which was simply the amount of how much did the band, I guess back then it was band 4, the 10.7 micrometer on GOES 13 change in the last 15 minutes. So forecasters like that. But there was also some feedback that said, it'd be nice if there was a way to say, okay, we have this cooling, what's the probability that that's going to lead to a severe storm? So cloud top cooling evolved into ProbSevere, which is a probability that a specific object, a cloud object or a radar object, will produce severe weather in the next 60 minutes. Forecasters took that. They loved that product too because it's a probabilistic product that helps them gain confidence in issuing their warnings. But they also had suggestions like, well, how come you have just ProbSevere? And they noticed differences in the behavior of ProbSevere for hail, tornadoes, and winds. Why not separate those 3 out? So that was the developers in the building. This is Mike Pavlonis and Justin Sieglaf and John Centineo on the 2nd floor. So that the developers brought that feedback back to the building and worked on evolving ProbSevere into ProbHail, ProbTor, and ProbWind. So the forecasters suggest things to make the product more operationally useful. And the benefit of a proving ground is that the developers are there to understand and see for themselves why the forecasters want the changes that they want. When all this is known, you still have to periodically remind them, because if you go to a proving ground, you're still possibly going to go back to your forecast office where you've been comfortably forecasting for the last 10 or 15 years, and you're kind of in a, I don't want to say a rut, let's just say in a gentle, happy routine. And maybe you forget about these new products that you've learned about because the weather for maybe 2 weeks, you don't really need to use them. So here comes a weather situation where these new products might help. Comfortable routine and forgot about them. That's where I come and I will make a blog post that demonstrates. Remember that product you looked at back in June or July? There was an event this past week. It had a great impact on the forecast. This is how you could have used it. So this is a way to, as I say, gently remind the forecaster there are these products out there that they've learned about, that they have training material on, and that they can keep using. So just my summary slides. So I have trainer interaction with a subject matter expert to create these training materials. The trainer interacts with a forecaster at the proving ground. I'm sorry, I don't interact with the forecaster. Typically, the subject matter expert interacts with the forecaster at the proving ground, and they remind the forecaster the training material is there to remind the forecaster of the high points. Afterwards, we have blog posts to remind the users of what they've learned. And I have some links there if you want them, and my speaker contact information. And that's all I have. I'll be happy to take questions if you want.
Are there any questions for Scott or any of the speakers today? Lots of clapping. Karen says she likes your reference to habit as a happy, gentle routine.
I didn't want to say they're in a rut, but maybe they trying to be
Fantastic.
positive.
All right, last chance, everybody. Any questions for any of the speakers? Hearing none. Thank you, all of the speakers, and thank you to the speakers throughout the semester at the department seminars. We'll be moving to Zoom for our seminars next spring. So wherever you found out about this one, keep an eye on that spot, and we'll try to get the information out there. And all right, thanks everybody, and we'll see you. Have a good break, and we'll see you in the spring.